Greetings and salutations, everybody. Beautiful day for a Ocean Protect webinar. Sean, how are we?
Hey Brad, good. As always,
Very
always good to
good.
catch up with you, buddy.
Cool. And we were just talking before, you've survived Tropical Cyclone Alfred.
We did, yes, we did. The kids are excited because they can now officially say that we lived through a cyclone. So,
Very cool. As we all can in Southeast Queensland, and welcome to everyone who's dialing in from all around the country, but particularly a big shout out to people in Southeast Queensland and Northern New South Wales who've gone through a tropical cyclone. So well done to you. Hopefully you're catching up on washing and repairing fences and roofs and all that sort of stuff. So, and haven't eaten too much ice cream over that period in lieu of failed freezes. But welcome to another amazing webinar. We're going to dive straight into today, and it gives me great pleasure to introduce our presenter back again, Sean Quilty, Director of Quilty Engineering Hub, engineer to the stars, a passionate educator. He's been with TAFE Queensland and inspiring the next generation of Stormies for at least 9 years now, and a super popular presenter. Hence why we get him back. This is his second appearance for this year's webinar, Stormwater Fundamentals series. He's already knocked off one this year, and he's got one more to come after today. And if you're just coming across Sean for the first time, he actually presented 3 of these webinars last year as well, to critical acclaim, I should point out. But we're here to talk about GIS for stormwater engineering. And just a reminder, folks, before we dive into the official proceedings, obviously this is the second of the Stormwater Fundamental series for the year. A whole bunch of cool cats presenting. Sorry, it's the third. Sorry, what am I saying? Sean's second. It's the third overall. We've got a whole bunch of cool cats presenting from. We already had Mukta from eWater for the first one, and this is his second, and he's got one more after today. And then we've got guys from Optimal Stormwater, Organic Engineering, and Ocean Protect, and they're all free. So free training, free CPD. If you're not already registered, feel free to jump on our website to register for the other ones. And if you're keen to keep a finger on the pulse of these events or similar type things, just be sure to subscribe to our newsletter. And just a reminder, folks, before Sean kicks off, and we always get asked this, but yeah, the slides and the recording from today will be made available on our website. Generally, it's about a day after the webinar. So if you're keen to watch it again or you missed it somehow, feel free to tune into that. And the slides will be there as well. And we always get a whole bunch of requests for CPD forms. As part of your registration, you would have nominated whether you want a CPD form. So that will be emailed to you shortly after the webinar. And apologies, we're still getting our head around how to do that most effectively. But I think we've got our system in place now. So that'll happen fairly streamlined. And apologies for anyone who's been waiting on a CPD form. I think we're all up to date. But if we've missed you, just let us know. But if you haven't nominated for a CPD form and you like one, just drop us a line at marketing@oceanprotect.com.au. Cool. I might pass you on to the esteemed Sean Quilty. And again, just a reminder, folks, Sean is a legend. If you're not already aware, he's director of Quilty Engineering, engineer with at least 18 years experience, all things engineering and stormwater and all the cool stuff. And he's an awesome presenter. So please take it away, Sean.
thank you, Brad. Such kind words. You see, this is
I
why I
know,
like
right?
Brad so much. Every time I see him, I just get, it's all flattery. No, welcome, guys. Thanks for taking the time out. Today, we're going to be looking at GIS. And sorry, I'll just stop for a sec. This looks like it's, sorry, guys. Not sure why this is all jumping ahead. It shouldn't be jumping ahead like that. Just bear with me 1 second here. Just as Brad said, I'm such a good
I
presenter.
know you
I
let
come
me
up
down.
and
Yeah, put the moz on
I
you, Sean. It's like when you see a footy player line up for goal, and everyone's like, "Oh, he's a fantastic, kick of the footy," and then he sprays it and puts it out of bounds. So
oh, gee. I'll
put the
tell
moz
you
on you.
what.
Sorry, Sean. No pressure.
No. Hopefully this does what it should be doing. All right. Good. It stopped. It's not doing anything silly. So today we're going to be looking at GIS, and in particular we'll be looking at some stormwater use cases. It is still doing this thing. Sorry guys, 1 second. hopefully that stops that. So we will be looking at GIS for stormwater. So I have presented this for people, hopefully, that maybe have never even really heard of GIS or not really across what GIS is. So I'll give you a bit of an introduction into what GIS actually is first. And then I'll talk about how you can actually create your own system, I suppose, where you can basically get free open data, so free to the public information, and then present that in a map type of representation. And then we can see how we can focus that into the stormwater and civil engineering industry. Anyway, it might sound a little bit unknown, but I promise you, I'll walk you through it, and hopefully you should be a bit of a GIS guru at the end of the hour. So the first big question, what is GIS? So GIS, it stands for Geographic Information Systems. So this is where we start looking at technology that captures, analyzes, and interprets spatial and geographic data. This will integrate data from various sources to create layered maps for decision making. So essentially, the easiest way that I like to explain it is you're looking at the what and the where. So we just have information. It could be about anything. It doesn't even have to be engineering related, but we have information, but we're able to display that information on a map. So we're putting it in real world coordinates, and that's essentially what a GIS is. The best example of GIS that I usually tell people is Google Maps. That's a great example of GIS because you've got information, you've got points, you've got roads, buildings, you've got areas, and it's all represented in a true real world coordinate system. So that's the what and the where. That's essentially what GIS is. So some key components when we start to talk about GIS, first we need to understand that it's all about data and it's about spatial data. And when I say spatial, that means it's on a real world position, somewhere on planet Earth, if you like. So that's the information that will be tied to geographic locations. So we've got the data. The next thing that we need is the software. So this is where we need some tools to start to manipulate this data, to analyze the data, and then to visualize or communicate what that information is. So we'll look at what software we can use, and there's free GIS software that anybody can download, and you can start using basically right after this session. You'll be able to download and then go straight into some GIS and start creating your own maps. So it's very accessible. Hardware. So in order to do this, obviously we need a computer. Now to run your own GIS, you just need your own computer. It doesn't have to be a U-Butte gaming system type computer either. Just a very basic computer is fine. But when we get the information, that's where we need some more sophisticated hardware. And that's when we start looking at GNSS, or more commonly sort of referred to as GPS devices. And that's where if you're recording any data, so if you're taking a photo and it's got the latitude, longitude, for example, that's one way that you can capture that information or that data. Now, obviously, when we get into the surveying world and you're capturing raw data, they've got some very sophisticated equipment, but typically from a GIS user perspective, we sort of sit on the other side where we just get the information and then we analyze that. But that's kind of where the hardware sits in it. And then obviously the people. So when we're looking at GIS, we need skilled professionals to be able to interpret this data, to manipulate the data in different formats, to understand coordinate systems and that sort of thing. But as I said before, after today's session, you will be skilled as a GIS user, I promise you. So when we look at the applications of GIS, I could talk for half the day about how you can use GIS in all sorts of different industries, in business and real estate and personal and all sorts of different things. But today we're going to focus on applications specific to civil engineering. So from a civil engineering perspective, we would use GIS for infrastructure planning, so designing our roads, bridges, all of our utilities, and making sure that they're designed accurately with regards to spatial information or geographically positioning them. We use it for asset management. So it's not just when you're designing and going to build, say, a road, it's the fact that we will have that asset for 50, 100, even beyond so many years. And so we've got to be able to monitor and understand how that asset is working or not over the next 50 to 100 years as part of its life cycle. So asset management plays a huge part in the GIS world. Environmental impact assessment is another great application that we use in civil engineering. So that's where we can analyze the impact of construction on our environment. We can analyze the environmental, habitat that we might be working near or over, and start looking at all sorts of different information that comes in from the environmental side of things. When it comes to urban planning, and I personally, I've always liked the urban planning side of things. I think all civil engineers, civil designers, and civil draftspeople, we all have a little bit of an urban planning, exposure. We do a little bit of planning, whether we have influence on the planning side of things very early on, or whether we're just exposed to that urban planning side. And I think it's quite interesting because normally we're so focused on the single site that we're developing, working on. It's really good to actually take a step back and have a look at the holistic approach of, say, a development that we're looking at. So in urban planning, we would have land use planning, so allocating space for residential, commercial, and recreational areas. We would have transportation planning, optimizing traffic flow, public transportation routes, and parking, and also disaster management. And this probably more so than ever. We've just had a cyclone reach land over the last week in southeast Queensland. So this is definitely on the forefront of a lot of people's minds. And perhaps a lot of you might have even had exposure to some disaster management dashboards that councils would have had. All of that is just basically GIS. It's information, but they're presenting that on a geographical map. Again, the benefits of GIS, I could go on for hours and hours and hours. I absolutely love GIS. There's so many good things about it, but just to touch on it and scratch the surface, it's really good for improving on our decision making. So we can make much more better informed choices based on spatial data and analysis of this data that we have. The more information that we have, the better our decisions are going to be. We can have a lot of cost savings. So we can look at our resource allocation. If we're looking at, say you're a local government entity, a local council, and you've got all of these roads and pipes and everything else, if you've got that in your GIS, you're able to analyze each one of those elements and decide which one needs more maintenance, which one's being maybe underutilized, and save a lot of money in that respect. Communication. So GIS is a great tool to communicate. It's a visual representation, which is really good for stakeholders, especially people that aren't perhaps engineering savvy. You can put a map together, and just through the way that you create the different layers and colors and labeling, you can really present a map that anybody can really pick up and understand exactly what you're trying to communicate within a matter of seconds. And sustainability. So when we're looking at the GIS data, we can look and decide how we can promote environmentally responsible planning and development as well. So heaps of benefits for GIS in the civil engineering space. So when it comes to the data, so GIS is all about information. There's heaps of different file formats that we can use. We can just take it literally straight from Excel. We can have heaps of information in Excel spreadsheets. We can bring that into a GIS. We can bring in images, geo-referenced photos, AutoCAD line work, point clouds, and all sorts of other GIS specific files. There's probably no information that I've come across that I couldn't bring into GIS basically. You can basically bring anything into a GIS. So once you have a GIS, so say you've got some software opened up, and we'll look at that in a couple of minutes. Once you have a GIS, a Geographic Information System, the next thing you need is data. You need to bring that information in. So I've got a couple sites that I'm going to show you now. So if you go home today and you install a GIS software, and I'll show you where you can get that, you can then go onto this website and then you can obtain free open data, we call it. So open data being it's free to use and it's open to the public. Anybody can access this information. So data.gov.au, this is a great repository for information. It acts as Australia's official open data portal, and it provides public access to all of their government data that they want to be able to share with the community. It'll allow you to search, explore, and download data sets from all sorts of different government agencies. And the main idea behind this is just to support transparency, innovation, and informed decision making by making this data freely available. So if you jump onto that website, you'll be able to search and download all of that data absolutely free. So this is just some information that you'll be able to obtain from the Open Data website, data.gov. You can bring in climate and weather data from BOM. You have environmental data sets, transport and infrastructure data, health and educational statistics. And this is where it even goes outside of the civil engineering scope. If there's other stuff that you're just interested in, you can bring in census, demographic statistics from the Australian Bureau of Statistics as well. You can bring in business and industry data, employment trends. There's all sorts of information. And once you actually start to sort of crack open these data repositories, you'll be overwhelmed with the amount of information that's actually out there. And then it's up to you to decide how you can actually leverage off of that information in whatever your role entails. The second open data repository that I'll share with you guys is Queensland Globe. So it's a bit of a focus on Queensland, but most states will have something similar to this. So on this website, this gives you not just a website where you just search and download data sets, but you can actually visually see those data sets as well. And so what I mean by that is it's an interactive mapping tool of all of Queensland. So you can pan and zoom just like you would in Google Maps. And then you can find anywhere you're interested in, turn on whatever layers that you'd like to sort of see. And once you see that data and you think, oh yeah, I can use that, then you can download those data sets as well. Similar to the national data repository we looked at before, there's heaps of information here. You're going to get property and land information. So that includes your cadastral boundaries, which is a great way to start any project. You've got aerial and satellite imagery, and then all the infrastructure, all the environmental data, protected areas, vegetation, water resources, streams, mining and resources information, LGA information, and flood and disaster mapping as well. There's heaps of really good information there for you guys to have. All right, so we kind of know what GIS is. We've got a little bit of theory there and a bit of background on what it is. It's basically information, but we're able to display that information on a map, on a real world coordinate system. We now know where we can find data, so open data, freely accessible data. This is the last piece of the puzzle, and that's the software. So we need some sort of software platform to start looking at this information and creating these maps. So that's where QGIS comes into it. So QGIS is free and open source GIS software. And I'm not affiliated with QGIS, but I absolutely love it. And I'm always advocating to use QGIS. Essentially, it's just a worldwide community that have come together and have developed this software over many, many years. And every single year, every single month, people are basically creating new plugins or new clever ways to actually use GIS data. And it's just constantly being updated in the software. So the software costs you nothing to download. It costs you nothing to run and install. It's all completely free. So with this software, you'll be able to create, edit, visualize, analyze, and publish geospatial data. So you can bring the data in and do whatever you like with it, and even produce outputs as well. It's a really user-friendly interface with really powerful mapping and analysis tools, highly customizable. So it allows the users to really extend its functionality through plugins. And then if you get into the scripting world, there's so much more you can actually do in there as well. If anyone's interested in that, or if you're getting stuck on QGIS or how to sort of install it and how to get your first bit of data, there's online courses that we have at Quilty Engineering Hub, and they start from $29. And again, with those courses, they're a lifetime ownership. You just pay it once and you've got that for the rest of your life. And there's hours of content in all of those courses. So step one, you'll obtain your data. So that could be through data.gov.au or through Queensland Globe. Step two, we bring that data in. So you'll download that information and literally just drag and drop into your software once you've installed it, and it will just bring up all of that information so you can start to look at it. Step three, you'll be able to analyze your data. Now, the most important, or the biggest advantage, I suppose, of GIS data is not visually what you see. You might see some stormwater pipes on a layout or might see a property boundary, but it's the non-graphical data that you don't see. That's where the power comes from GIS. For any of these elements, you'll be able to click on, say, a property boundary or a stormwater pipe, and then it will have all this extra information that whoever owns that data, they would have put into it. So you'll be able to click on a stormwater pipe, see the invert levels, see the material when it was constructed, the pipe diameter, or the property boundaries. You'll see the lot and RP values, the area, just really useful information. And so that's where you can really start to analyze your data, again, using this free QGIS software. Once you got the information, then it's time to communicate that to the end user. And that's where you'll be able to create your own maps, again, using this QGIS software. So you basically just zoom into where you want to focus on, turn on the different layers that you want, and then you can edit your maps to add logos, company logos, text, north arrows, scale bars, all the usual stuff that we'd put on a map. And again, all that's completely free. Right, so we know where we can get data, we know where we can get the software, we can start to create our own GIS. So these are some use cases where you might find it quite handy when it comes into civil engineering and specifically for stormwater tasks. So one of the first things that typically I'd recommend is getting a base map. So basically like a blank canvas for your project. So these base maps are basically streaming in live data into your project. So you'll be able to bring in, say, Google Maps or OpenStreetMap. You can bring in satellite imagery and property boundaries. And I think between the satellite imagery, some OpenStreetMap sort of maps and some property boundaries, it gives you a very good starting point to then start to layer on top of that all the GIS data that you might come across. So it really is like just that blank canvas before you start. And again, if you are interested, there's actually a specific online course where we walk you through obtaining satellite imagery, high resolution satellite imagery, and property boundaries for everywhere across Australia except South Australia. They don't have anything available, but every other state and territory. And so you could create your own GIS and you could have property boundaries and high res imagery for basically almost everywhere around Australia to start your project. And that's live data. So as you zoom into any site, you will get the latest information that's available from that data. So it's constantly being updated. Again, only 29 bucks and you're able to create that. And that's been really, really useful, particularly for people wanting to fast track their career. They've been able to create their own GIS, basically projects on the side. And then they're able to show that to their team managers or the design managers and actually say, hey, I'm not just drafting, I'm also creating GIS, or I'm not just on the engineering side of things, I can actually get into the software and create these maps as well. So if anyone's interested, please do jump online and see what you think about that online course. So that'll be the base maps. That's a good starting point. Some other things that we can do, we can access land use mapping. So essentially what we've got in this image here, it's just a subdivision, but I've just sort of split or hidden the land mapping on the left-hand side. On the right-hand side, you can see there's 3 or 4 different mapping themes. So it's basically, it recognizes aerial imagery. It does a whole heap of AI and clever things in the background, and it will recognize what is classified as urban development, if you like, or essentially impervious areas. Very low-lying sort of shrubs or grass, which is the yellow areas, and then vegetation that's a bit higher, which will be the green areas. And it even identifies water areas as well, water bodies, which is that little blue sort of area you might see there. Now, this is really useful, especially when it comes to flood modeling, because one of the first things that we need to do with our topography is actually to set, say, a Manning's roughness. And that really helps when you've got some automatic mapping that's already done a lot of the hard work for you. And then you can just slightly tweak and customize that as you need for your project. So this land use, this is again free data. It's publicly available. And this particular data set's all over the world. So you'll get that resolution all around the world. So land use mapping, really, really useful. Topography. This is probably one of the most important bits of data that you'll want to get for any project. So there's the 2 probably most common publicly available free topographical data is either the SRTM data or LiDAR. So the SRTM is a shuttle radar topography mission. Basically, they had satellites up in the sky and they thought, hey, what can we do while we're up here? They said, well, let's just take a whole heap of satellite imagery, take a heap of photos of Earth, the whole world, really high resolution, and let's just give that out to the public. And that was the SRTM, or part of that particular mission. So what that gives you is actually the physical topography, the elevations of the whole world at a 1-second resolution. Now, when we talk about 1 second, if you think about the world as a sphere or a circle, if you like, if you cut a plane through it, we've got degrees, minutes, seconds. So that 1 second is that one slither, and that's the resolution or the size of your cell. And that equates to about a 30-meter by 30-meter grid. So the fact that we've got the whole world and the surface topography at that sort of resolution is pretty impressive, and it's pretty good for very large scale projects or initial sort of concept, maybe existing sort of surface features you want to look at. If you wanted a bit more detail than that, and let's be honest, if we're starting to look at urban planning and urban development, 30-meter grids are not going to get us too far. That's where we can start to look at LiDAR. So LiDAR is a bit more site specific, and there's some repositories. Again, we've got a course for this that will show you how to obtain all this LiDAR for free, and then how to actually manipulate the LiDAR to create maps like you can see here on the right. But that LiDAR can actually go down from 30-meter grid resolution right down to 1 meter and sometimes half a meter, depending on where you are in Australia. So that's every 500 millimeters, they're picking up the elevation of the topography, and that will cover, whole cities essentially. So that's really, really useful, and that's how we can get that topography information as well. So once we've got the topography, we've got the actual surface itself, we can really start to analyze this information. And one of the best things that we can do is start to look at what we call the stream order. Essentially what it does is it'll look at the surface, the grid, the cells that you have, and it will basically run a whole heap of algorithms in the background and basically show you pretty much where the lowest points of that grid is. And then what it can do is it can join up basically the falls, and it will create what you see here on the right-hand side is the streams. So if it was to rain, the water will basically accumulate along these sort of stream paths. So this is where you can build your own stream network from your own LiDAR. Again, it's cost you nothing so far. It's free software, it's free data online, and now you're able to actually physically see where the water's going to be running in these streams. Now, typically, the stream order analysis is used in rural areas where you've got these large natural catchments. But I've been using it in urban areas, which is super handy because a lot of the time, if you've got a development and you're trying to discharge stormwater, say, out onto the road, a lot of people will have to just stop their analysis at the boundary because it's very hard to analyze a full, neighborhood or 4 or 5 street blocks. But if you look at this stream order, this will very quickly tell you or give you an indication as to how much water might be accumulating on a certain part of the road. It's a bit hard to see, and maybe in the questions and answers we can probably go in a bit more detail. But there's a main road running north to south here, and you'll see on the left-hand side of the road there's quite a big accumulation, or these streams are starting to sort of gain more and more cells. So there's going to be more water that'll be flowing on the left-hand side of this road than on the right. And sometimes the topography, it's a bit hard to tell. Certainly with just aerial imagery, there's no real way to tell if that's going to happen. But this stream order will actually allow you to get into that really next level analysis. And the best part of this is when you create these stream orders, you're letting GIS, the software, actually crunch all these numbers and analyze all this data, and you don't actually have to do it. A few clicks of the button, and then you get this sort of output. So super handy, and not just for rural catchments. You can use them for urban, depending on what you're trying to look for. So we've got topographical information. We've got these stream orders, so we can kind of see where the water is going to accumulate. Now we can start to look at catchments. And this is where GIS can automate this catchment delineation for us. Now, you don't have to automate it. You can just look at contours, your topography LiDAR that you might have. You can look at the contours, you can look at the aerial imagery, and you can start to draw your own catchments manually, which I still do pretty much on every project. But you could also let GIS, the software itself, actually do some of this hard work for you. So in this case here, I've just picked on a point on one of these streams, and then I've let QGIS actually analyze that data, analyze the streams, analyze the surface, and it's drawn for me that catchment where all that water would then contribute to that one point. So it's great for a first pass. Clearly, this is an urban setting, so your catchment won't follow exactly the topography. You're going to have fences and all the urban sort of environment that will also affect your catchment. So I'm not saying this is finished, but it's a great first pass to just get a rough idea of how big that catchment might be. This is also really good to look at when you're trying to gauge your tailwater levels for stormwater pit and pipe design, and you're trying to plug into a system. And everyone that knows me knows that the first thing that I ask is, what is the tailwater level? And so sometimes you can't work that out, and it's too conservative to adopt the national standards of 150 mil below the surface. So this might be able to help you in gauging how big that catchment is. And then you can start to crunch those numbers and see, well, how much do you think that existing stormwater system is actually at capacity? And this will help you formulate that justification to then start to talk to council about that as well. But I'll stop there. I'll probably talk too long if I keep going down that path. And then we have flood data, and especially in southeast Queensland and in WA as well, around the Pilbara and sort of central region, we've had a couple cyclones hit there. So flood data is probably in the front of a lot of our minds. So this is where you can get your GIS software to actually incorporate, again, publicly available free data from online. So in this example, this is Brisbane City Council's flood mapping, and it's just one of the flood layers, if you like. But that's been able to, I've been able to bring that into my QGIS project. So that's just constantly streaming in the latest flood data that Brisbane City Council has. So you can jump online and you can see that data, which is great. But if you have your own GIS software like QGIS, you can then put on your own layers. So you could bring in the architectural layout or the subdivision master plan, might be a PDF, but you can bring that into your GIS software and see how that interacts with these flood layers as well. So really, really useful. Again, when you get this free data, you can actually bring that into your own QGIS software. So the real question is, do you really understand your catchment? And the answer would be, well, if you've got GIS software and you've got access to all of this data, you can really truly understand how your stormwater catchments are going to behave. So you'll be able to bring in topographical data. So you could bring in LiDAR. So we've got all the contours you can see there in the bottom image. With that LiDAR, we can then analyze these stream networks and see how the water will actually flow and interact, what roads might be conveying maybe more water, stormwater runoff than others. So that's the stream network you see in that sort of top middle image. We could also bring in council's stormwater infrastructure, so the stormwater pits and pipes. So that information is also freely available. So we can add that to our QGIS project as well, and that's what you see on the left-hand side. And then we can get all this information together and create our own customized maps. So you could start to produce these. Maybe they might be for a bid proposal. You might be looking at a due diligence report, maybe engineering services reports, stormwater management plans for council, or you might be working within council. You might need to produce some internal sort of mapping as well, maybe for some disaster planning, maybe for asset management. There's the list goes on. You can use it for so many different things. But when you create that map, that's where you can very quickly communicate to the end user exactly what that catchment's doing or what that information. It doesn't even have to be a stormwater catchment necessarily. So if you do want to create your own GIS, hopefully you've got enough information here to at least get started. So the website was provided where you can download QGIS, and you've got two websites for freely available public open data. So you can literally just jump on, install, download some information, and then start running away with GIS. Now, if you need a little bit more help, obviously we've got online courses there starting at only $29, and that will get you free access to GIS software, hours of content where I'll explain how to use the software, where to gain information, and then I also provide data sets as well. So you can just drag and drop information that I've already cleaned up and sort of got prepared for you. So you can start to really understand how the software works. And again, lifetime ownership. There's no subscriptions. It's just a one-off payment. Of course, if you want the next level, I suppose, of education and GIS skilling, book a workshop, and then we can present a workshop in-house. So we do in-house training anywhere around Australia, or we can do virtual training via Teams as well. So this is great, especially for managers. They're saving time. They don't need to upskill their own team and spend their time away trying to train up the whole team itself. I just come in, do the training, and then leave you guys to it. It increases staff engagement. So when we have these workshops, especially the active ones, we're getting people discussing and asking questions and talking about, problems they might have come across, or we'll teach certain things in GIS and think, oh, we can actually use that workflow to do a whole heap of other things as well. So it's really cool hearing those sort of discussions within the team. Everyone walked away from these workshops absolutely pumped. If you need to achieve your professional development goals, if you've got PD goals that are sort of hanging around, you haven't quite got there, these workshops are a great way of ticking those goals off for the financial year. Fast tracking your career, obviously, and collaborating across departments. So one of the best feedback that we get is certainly young professionals when they're trying to sort of climb the ladder. To add GIS to your skill set is absolutely amazing. And we've had a lot of feedback where that's really helped them sort of propel themselves from just simple drafting exercises and not really taking on much responsibility. And then they just all of a sudden launch into GIS. And now they're starting to get into design, and they're starting to really work with engineers in the sort of the analytical side of things as well. So if anyone's interested, please reach out, and we can help you out with workshops, or you can get onto our online courses. And of course, if you haven't connected with me on LinkedIn, don't be shy, please connect. And yeah, hopefully we'll carry on this GIS discussion after today. All right, thanks, Brad. I'll hand it
Thank you,
over to you.
Sean. Great presentation as always. And just a reminder, folks, please put any questions in the Q&A panel. But we already have a bunch, so I'm just going to dive straight into it. So first question, I think straight up the bat was Rowan from East Gippsland Shire Council in Victoria. So welcome, Rowan. Rowan asks, for land use mapping, how are you getting the different surface category? Would you be able to please elaborate?
Yeah, I unfortunately can't take credit for that. So when you download the land use mapping, it's already there. So there's no classification that we do on our end. You just download the data set, and I forget the entity, I suppose, that created the data, but it's a worldwide data set. But whoever creates that data, they've actually classified it themselves already. And so that would have been based on satellite imagery, I believe, and it would have been a whole heap of algorithms in the background. So basically monitoring and training or teaching the AI side of things, I suppose, or the algorithms to actually recognize vegetation versus roofs versus, like, even now that they've got, like, the land use mapping is one side, so they can identify vegetation versus, say, hard impervious areas or roads and that sort of thing. But they've even got to a point now where you'll be able to look at satellite imagery, and you can actually pick out solar panels. So there's a whole other, business there, I suppose, where solar panel companies are basically take a photo of the satellite imagery, and it'll recognize how many panels you have or what surface area you've got. There's another one where it recognizes cars even. So it'll actually put an outline of every single car that it'll pick up on satellite imagery. So all of that classification is done before you get the data. So that's done by basically whoever's providing that data itself.
Pretty amazing. Another question from Rowan regarding stream order. They say, I found 30 meter LiDAR is not useful. What LiDAR accuracy have you found useful? Is it, say, like a 1 meter LiDAR?
Yeah, generally your LiDAR will be 1 meter, which is pretty useful. I've found that that's pretty good resolution. The stream order data that we saw beforehand, where you could kind of see those streams quite intricate levels, that was all 1 meter LiDAR. So agree, 30-meter LiDAR is not going to be great unless you've got absolutely massive catchments, or if it's relatively sort of undisturbed natural environments. You're just looking at the general gullies and valleys, which are pretty obvious. But yeah, 1 meter is absolutely fine. As I said before, you can get half-meter LiDAR as well, which is even better. Again, I love working with that LiDAR. It's very, very, I won't say accurate. We all know there's a bit of a caveat with LiDAR. There can be a bit of a discrepancy, but it's very relatively, the surface that you get is very good. Yeah.
So on that, you talk about the accuracy. Obviously, LiDAR can't penetrate vegetation. Is that right? So when they're beaming
Yeah.
the thing, it doesn't really accurately reflect ground level. Is that correct? If there's a whole bunch of
It-
trees in the way?
to a to a certain extent. So correct, the lasers basically don't penetrate anything. It'll just bounce off of the vegetation. But even in very thick vegetation, you'll get, maybe one or two beams per, I don't even know, just making up numbers, but say a beam every 100 beams, 99 will bounce off the trees and the leaves, but one beam will penetrate. And so it comes down to the post-processing of that information. So if they see that, 99% of the points are up here above, your tree canopy, but then there's like 10% are sort of down lower, then they can say, well, that bottom part would be what we call the digital elevation model, whereas the top part would become the digital surface model. So that the overall surface physically what it is, but you can actually separate between. Now, when you get LiDAR, you can get it in a couple different formats. If you just get it in the basic DEM format, they've already classified, stripped out all the stuff they don't need, and then you've got the terrain or the ground, if you like. But you can also get LiDAR where it's an LAS or a LAZ format, and so that's like a point cloud data. And that's where you'll be able to actually toggle between vegetation versus the ground versus buildings. They can kind of classify between those as well.
Cool. Apologies if I'm getting drowned out by the rain. It's probably still lingering tropical cyclone maybe. But question from Yasbinder Singh, which is the best name today I've seen on the webinar list. So and they're from City Hobart. So welcome, Yasbinder. So they ask, where can we download the land use data?
I didn't have a link there, but if you want, get in touch and I can find out where you got it. There was two. Trying to think now. There were two repositories that I've used. One had 30-meter resolution, but I've just more recently found a 10-meter resolution for land use mapping, which is super useful. 10 meters is getting pretty accurate. Send me through an email, and I'll see if I can flick something through to you.
Well, and just a reminder to everyone watching, I'm getting a lot of questions in the chat. It's impossible to keep track of them. So it's just a reminder, if you've got a question, please put it in the Q&A. Unfortunately, if you put it in the chat, I probably won't see it and get Sean to answer it, unfortunately. So just a reminder, a lot easier to manage if you put questions in the Q&A. First come, first served. Another question from Gibran Ray Hansa says, have you got any recommendations if there is a gap in the data? For example, lack of LiDAR or shape from the database?
Mm. Yeah, that's a good question. Whenever you need to create new data, there's always going to be a bit of a risk. So, yes, you can create new data. I guess the short answer is, if you had LiDAR and there were some holes, there are algorithms that the GIS software can run automatically, and it will fill those holes up. It basically stitches between where your data is. But again, there's a bit of a risk, because if you had sort of 2 points and then there was like a bit of a hill in between them, and then you just drew straight across, you might be discounting that particular hill or depression or something. So there's always going to be a bit of a risk there, but you definitely can. You can manipulate any data that you bring into GIS, in particular QGIS, and you can add basically fill points where those holes are, and there's all sorts of other mesh or terrain alterations, I suppose, that you can do as well.
Just trying to, another question from Yelena Shrep from Stantec. Yelena asks, do you have any courses for ArcGIS or QGIS to create your own overlays, like for flood events, coastal erosion overlays,
Yeah.
etc.?
Yep. So Quilty Engineering Hub, the way that we operate, we want to educate as many people as possible and make it as accessible as possible. So for that reason, we adopt QGIS because it's 100% free. It's open source, very grassroots. So we don't do any ArcGIS training at all. That's a paid software and a paid service as well. And so we figure, all of our graduates and young professionals, we don't have the money to actually buy standalone software. So it's always focused on QGIS. We do have online courses where I'll give you some data sets and you'll start to sort of play with it, and I'll explain how you can manipulate the data and labeling and all that sort of stuff. When it comes to creating brand new layers and using those overlays, you'll get some of it in the GIS courses, but really the workshops are the way to go, because we'll start with, for example, we've got 2 modules that are probably the most popular. The first module is a half-day course where we look at data sets that I create, and we look at topography and stormwater and sewer and water, property boundaries, and how we layer it and how you can create your own customized maps for your own business. And then the second module, it's also a half-day course. That's super popular because then we start to link online repositories and start streaming that data into your project. And so once you can do that, you just basically level up on the information that you're using. Yes, short answer is yes, we definitely do in courses, and then the workshops as well. The biggest benefit of the workshops, I'd say, though, is we go off on tangents. So I'll come with a whole heap of information prepared, a whole heap of content, but then depending on the businesses, whether it's with councils or whether they're private companies, or if it's individuals only that are just trying to sort of fast track their career, I'll present something and then they'll say, well, what about this, this, and this? Or I've got a problem ABC. How would you solve that? And we'll have a bit of a brainstorming session, I say, well, you could use, these workflows that I've got here, you could use that slightly differently. So going off on those tangents are really beneficial, I'd say, because they'll probably answer even more questions than what you originally were hoping in the workshops. And hi to Lena again. I think you're on the last workshop as well.
Oh, the questions are coming in thick and fast. It's not GIS related, but Rowan asks tailwater depth. You touched on it. Is there any chance you could elaborate on tailwater depths, maybe from a GIS perspective?
Absolutely.
Look out.
Um, how much time do we have, Brad?
We've got
No,
9 minutes,
it's
Sean, and there's
if
a lot of other
if
questions.
if you jump back to the Ocean Protect webinar that we did last year, the links will be somewhere. I'm sure Brad will be able to pull them
Yeah,
up. The I think it was the pipe design. We
yeah.
talked about tailwater for a good 10 or 15 minutes and how they kind of affect your stormwater design. Um, from a what I was sort of touching on before, if you're looking at a catchment analysis, you need to, if we're designing stormwater and the water's going to rush somewhere, whether it's at surface or whether it's underground through pipes, our stormwater runoff is going to hit some sort of water body most of the time. Either hit water inside pipes that are already there, or it'll enter into a drain that might be already half full or full by the time our flow hits it. That's the tailwater level. So what are the water levels at the boundary that we're trying to look at? And that will can significantly affect how your stormwater infrastructure works, because you're all of a sudden hitting this body of water and you'll get a bit of backwater effect. Yeah, I'll keep it there because it will probably go on too long otherwise.
Cool.
But more questions, send an email through and we'll try to get a
Cool.
response.
Another question from Fake from Manningham City Council. Basically said, is there what other GIS softwares are available? So I think mentioned Arc/Info, Weave, ArcGIS. Are there any others that people could be utilizing?
Oh yes, look, more and more, most of the modeling and drafting software that we use in civil engineering incorporates GIS. It's sort of gotten to that stage where GIS is really, it's nothing new, it's fundamental. And something that I tell people as well, if you're a draftsperson, for example, in the last sort of 5-7 years, I've been really trying to upskill any draftsperson I'd work with to get into GIS, because it's a fundamental skill that you need to have. Similar with engineers, if you're an engineer and even if you're not into the software side of things, you still need to understand the GIS and be able to analyze that data as well. So for example, I mean, QGIS and ArcGIS, they're probably the main ones where it's specifically GIS. It's really focused on that analyzing the data. But if you get into 12D, civil 3D, civil site design, InfraWorks, all the main civil engineering modeling drafting software, it has GIS components where you can import this same data and then map it and visualize it as well. It's probably not as good, I suppose, as the main GIS software packages, but they might offer maybe 10% of the functionality in there as well. So yeah, I guess to answer the question, it's sort of becoming prevalent in almost any bit of software that we use.
Cool. Question from Chris Tomini from Brisbane City Council. Chris asks, have you had any luck mapping LiDAR into 12D and being able to apply attributes such as pipe diameters and depths for stormwater infrastructure? Or is it still a very laborious process to translate that information?
Hi, Chris. I think that was maybe a bit of a loaded question. We've worked together, and he's probably seen some of my handiwork in the background. Yes, you absolutely can. It's very easy to bring in LiDAR into 12D, and this was a few years ago now. But I was sort of playing with GIS data where you can basically, I'd run a Python script, and it will basically take GIS data from councils, say stormwater pit and pipe design, and basically grab the information and you'd throw it into 12D, which is a civil engineering modeling software, and it will actually map all of that data so it doesn't come out as just lines and points. It'll actually come out as structures. The invert levels of the pipes will be set in 3 dimensions. The pipe diameters will come out as physical 3D pipes. So yes, the answer is you absolutely can map that data. Same for InfraWorks as well. You can bring that in and do it that way as well. It is still a bit of a laborious task, but if you can set it up right. And it'll take a little bit of time in the front end, but if you can set it up correctly, going forward, it's an absolute breeze. A few clicks of the button, and then it all just sort of comes out. But I will just point out that when you're using data, especially when you get into the world of GIS, the data's only going to be as useful as, I guess, the information that's provided. It's sort of rubbish in, rubbish out philosophy, I suppose. So if you get council's data, for example, with stormwater pit and pipe network, if they haven't physically put in the attributes like the invert levels, then you're not going to get those. So somebody has to physically create that data to a certain level of quality. And so if that data or if those attributes aren't in there, then you can't really do much more with it. So when you do start getting into the world of GIS, don't expect everything to be perfect. It really depends on the quality of the data that you're actually getting.
Well, the questions are still coming in thick and fast, and apologies, we've got 4 minutes left. And if I don't get to your question, obviously Sean's contact details are here, so feel free to reach out. A lot of questions around the Quilty engineering courses, so I might just forward them directly to Sean. But
Yeah, definitely.
yeah, question from let's go with Alicia. So I think about yeah, Alicia from Hobart. Another one from Hobart. Alicia Camargo. They ask. Are the stream and catchment functions integrated into QGIS or are they downloaded as plugins?
Yep, good question. They are downloaded as plugins. I use PC Raster. I've been using that for a while, and it's quite robust. There's a pretty healthy sort of support network online for that as well. So PC Raster, that's a plugin you could use. There's some new ones that's popped out. There's Whitebox tools. I haven't really played with those. And then there's some older ones when you start looking at Saga, SAGA, and basically any of these plugins, all they really are just a series of Python scripts. And I have zero capability in Python scripting. I'll be the first to confess to that. But I've let people much smarter than me actually create all these Python scripts and they put them together in a plugin. So basically, as you open up QGIS, you have your little processing toolbox and you'll have all these little plugin functionalities, for example, the stream order. And you literally just click the button, select your topographical data, and then just hit run, and it'll just create those streams for you. So it's a bit fiddly to install and sort of understand, but once it's up and running, it's very, very effective. That's another workshop that we do offer as well when we get into the sort of stream orders and that sort of thing. So if you're interested, yeah, do get in touch. We could probably come over and teach you in-house or virtual.
Well, question from Peter Chambers from Muswellbrook Shire Council in beautiful New South Wales. Peter asks, is there any consensus or recommendations with councils opting in or out for open source of their GIS systems where asset maturity is in development to avoid decisions made on errors and inaccurate data? Great question.
That is a great question. I'll only answer from my opinion and from my very limited sort of knowledge, I suppose. But I believe, and this goes right back to, when I started my career, and Brad, you probably got some similar stories where we'd start a project and we'd need topographical data and we need some property boundaries, the most basic start of any project. And it used to take us jumping onto the phone, talking to a physical person when they're available and asking for some LiDAR data, asking for some property boundaries, and then it will take a good couple of weeks. We'd pay a couple $100 every time, and then we'd get this tiny little bit of information where it'll be like our site plus an extra couple boundaries, basically, and it'll be just 2D line work in AutoCAD, a DXF file, which is pretty useless. And then LiDAR data, we'd get a tile 1 by 1 square kilometer of data, and it'll be, if we're lucky, 1 meter grids. But the problem was we would have to do that for every single project. And so we were burning so much time, so much energy on their end as well, council and state government, I forget all the acronyms, Department of Natural Resources, whatever they were called back then. Everyone's burning all this time and you're just getting this really rubbish, very low quality data. Anyway, this is just on my perspective. Now imagine the whole industry working to that sort of effect. So as I understand it, the federal government, this is like, I don't know, maybe 10 years, maybe a little bit more, sort of came across this and said, well, it's not just Queensland, it's all of Australia. we got all this information, and all these councils are not wanting to share this information. And then all of a sudden, the industry is really being hampered by it. And we're burning a stupid amount of time, effort, resources. The economy is stalling. So they brought out this federal legislation. So this is like law. And they basically said, we need to enforce open data, which basically meant every local government authority, if you have that public information, so information on roads and pits and pipes and everything else, you need to give that information up. That needs to be freely accessible to the public. And that will then open up the industry and then stop that bottleneck. And since then, the whole GIS world it's exploded, but the civil engineering industry has only just slowly started to realize and started to get on board. But that is my understanding of where it comes from. And that's why about 10 years ago, 8 years ago, all these councils started to basically create and open up these interactive maps, which was their own online GIS portal with all the information freely available. It wasn't necessarily because the councils maybe wanted to, it was the federal direction that said, no, this is now legislation, you have to share that information. So again, don't quote me on that. That's just my dumb civil engineering sort of take on it. Maybe there's a few other intricacies in there, but that's sort of where it came from. And every single interactive map, every single GIS bit of data that you download, it will always come with caveats basically saying all care, no responsibility. And that's from council. That's also from private industry. Like I work in the industry as well. Anytime we create a map, it always comes with, we're just showing you data that we've received. We haven't created it. If it's wrong, it's not our responsibility. We'll do the best that we can. All care, no responsibility.
All right, that's a wonderful trip down memory lane there, Sean. And look, I remember back in the day where you'd have big maps in cabinets, and you'd beyond what do you call them, metal rods, and you'd hang it out and
Yeah.
whatever. And if you need an aerial photo, you need to go down to Queensland Maps, I think, down at Vulture Street. You pay money and measuring areas with you remember the planometer or whatever it was called? It was like, long story short, the GIS, the world has transformed our entire industry for the better. And certainly, I never got training, and I'm sure a lot of people haven't got training on GIS. So for you to give up your time and share some of your GIS experience, it's worth its weight in gold. You've been bombarded with questions here, and apologies to everyone we haven't had a chance to get questions to. If you've missed out, please contact Sean. So apologies. Just to write out some names: Rowan, Arban, Breach, Mobashwa, Fayik, Thurka, Peter, Winston, Navnet, Matt, Caitlin, Paris, Paul. Apologies in advance for not getting to your question, but please reach out to Sean directly, and because he can talk about this all day. Clearly, just a reminder: if you want to get the slides and the recording, it's going to be on the Ocean Protect website in the next day or two. And obviously, we'll aim to get your CPD forms out to you ASAP. But if you haven't received it in time, in the next week or so, just feel free to email us. But thank you, everyone who's dialed in today. And thank you very much to Sean for giving up his expertise again for another stellar Stormwater Fundamental Series webinar. So well done, Sean. Awesome work.
Thanks, Brad. No, thanks for having me.
Looking forward to seeing you the next one.
Absolutely. Thanks, guys. Thanks for taking the time.
Boom, boom, shake the room.